Okay, so let's look at an example using the empirical rule to find the percentage of values. So suppose that electrical bills for the month of May in one city have a bell-shaped distribution with a mean of $119 and a standard deviation of $18. Use the empirical rule to answer the question, approximately what percentage of electrical bills are between $101 and $155? So there are two different ways that you could do this problem. The first way, which is the way that your book does, is by filling in the numbers on the normal distribution. So essentially, you just fill in all of these different values, 1, 2, 3 standard deviations away from their mean, until you figure out where the numbers that you are interested in are. In this case, we're interested in the x values of $101 and $155. So those are the values we need to know where they are. So to do this, you start out by putting your mean on the graph. So our mean, in this case, is $119, and the mean is always in the middle. So $119 is in the middle. As we go to the right of the mean, we're going up, and so we're going to add that standard deviation every time. So if I want to find out what one standard deviation above the mean would be, then I just take that mean of $119 and I add my standard deviation of $18 to that. And so that one standard deviation above the mean value is $137. Well, $137 isn't the value that we're interested in, so we have to keep going. So I go up again, one more standard deviation, so I'm going to add another $18 to it. So I already was at $137, and so I'm going to add another $18 to go up one more standard deviation. And if I do that, now I'm at $155. Since this is the x value I'm interested in, I can stop at this point. And I know now that my $155 is 2 standard deviations above the mean. So we do a similar idea to the left-hand side, except since we're going to the left, we're getting smaller. So we're going to subtract that standard deviation off. So I start at 1 standard deviation below the mean. So that's going to be the mean minus 1 standard deviation, so $119 minus the $18 standard deviation. And that gives me $101. Since that's the other value that I'm interested in, I can stop. I don't need to fill in any of these other values on that ruler, if you want to think about it that way. So you only need to find the ones you're interested in. So I know now $101 is 1 standard deviation below the mean, and $155 is 2 standard deviations above the mean. So that means to find that percentage, I'm just going to add up all of the percentages in that area between the two values. So my final percentage is going to be the 34% plus the 34% plus the 13.5%. So if I do that, so I'm going to have 34% plus 34% plus 13.5%. And so I find out there's going to be approximately 81.5% of our data values for electric bills between $101 and $155. So that's the first method. The second method, so we're still interested between $101 and $155. But this method uses z-scores. To me, this method is a little bit easier because you don't have to find every single value on that ruler. You're just finding the ones that you really care about and figuring out exactly where they are fairly easily. So to do that, so we still know that our mean value is $119 and our standard deviation is $18. So we just have to do the z-score calculation to figure out where on this normal distribution these values lie. So to do our z-score calculation, so remember z is always data value minus mean divided by standard deviation. So our first data value, with the empirical rule, you have to do this for both values because they may be different numbers of standard deviations away from the mean. Remember, if you're doing this with Chebyshev's theorem, you only have to test one number. So I still do the same idea. So my data value for this first one, $101, minus my mean of $119, divided by $18 standard deviation. And so I do that calculation and I get a z-score of -1. So that tells me I am 1 standard deviation below the mean. So my z-score is there. So I know where that location of that $101 is now. Notice that is the same location that we got when we did that by filling in the ruler. Similarly, if I do the same thing for that other the other x value, so z is $155. So $155 minus $119 divided by $18 standard deviation. And I do that calculation, and I'm going to get a z-score of 2. So the positive 2 indicates I'm 2 standard deviations above the mean, which again is the same value that we got when we filled in the ruler on our normal distribution. And so then you just do the same thing. You add up those percentages in between, and you should again get 87.5% because we're looking at the same region. So the only difference between these two methods is how you figure out where those data values lie on your normal distribution.